Hey everybody, this is Gradius, and this is a video for working with exponents and division, so finding powers of quotients and simplifying expressions by using the properties of exponents. So this is the second video. So if you have not watched a video for multiplying with exponents or product of powers, I would like for you to go back and watch that first because this is going to use some of the things that we learned in there. Okay, so first thing, let's go ahead and talk about division and dividing exponents. Now we're going to get into some more complicated scenarios. So what I have here is I have two numbers with the same base. So I have a to the sixth power divided by a to the second power. So I have the same base, and I have exponents, and they're being divided by each other. So what this really is, if I were to expand this out into expanded form, so write this all out, a to the sixth power is just a times a times a times a times a times a. So I have six a's up here. A to the second power is just a times a. So if I were to write all this out to what this is all really means, this is what this all really means. This is a to the sixth power divided by a to the second power. Well, what we can do though is if we notice, we can actually cancel things out here to simplify this. Because if I have a divided by a, no matter what the number is a, it's going to be 1. Okay, because if I had 1 divided by 1, that's 1. 2 divided by 2, that's 2. That's 1, sorry. That's equal to 1. Okay, any number divided by itself is 1. So if I have a over a right here, it's equal to 1, and then 1 times a is just a. So they kind of can't, what they do is essentially they cancel each other out. So a and a cancel each other out because a divided by a is 1. I can do that here as well, a divided by a. Now I have no more a's down here. What I'm left with is 1, 2, 3, 4 a's after they cancel each other out. And what I'm left with is just 4 a's is a to the fourth power. There's nothing in my denominator, so I don't even need to write over anything. I can just leave that as a to the fourth power. So that is what we were doing when we were dividing exponents. Okay, so let's actually look at an easier way to do this. When dividing powers with the same base, we can just subtract the exponents. Okay, so if I have 7 to the ninth power over 7 to the fifth power, I could write this out and expand it like we did back here. Okay, I could expand it out. So this is 7 times 7 times 7, 9 times over 7 times 7 times 7 times 7 times 7, 5 times. Or what I could do is I could just look at my exponent because these both have the same base of 7. I can take a look at my exponent here and I can just subtract them. I have 9, 5, so I can just do 9 minus 5, which gives me 7 to the fourth power. Okay, and I'm done. That's all I have to do. Let's keep it simple so we can do a little bit less work. So it's just 9 minus 5, which is 4. If I have a negative exponent down here, it doesn't really change anything. I'm going to do 7 minus negative 3. I have the same base, so this is going to be 12 to whatever my new exponent's going to be. I know it's going to be a base of 12. 7 minus negative 3. I'm just subtracting. Well, this just becomes plus plus, change, change. So now I have 12 to the 10th power. And that is my final answer. So when we're dividing, when we have quotients with powers or quotients with exponents, all we do is we subtract the exponents and we're done. Okay? So now let's kind of change this up just a little bit. So now I have a divided by b, and all of this is raised to the second power. So if we remember from the products, from when we did multiplying exponents, when we have the exponent and we have multiple pieces inside and the exponent's outside the parentheses, all of this is being raised to the second power. So really what's happening is this a is being raised to the second power and this b is being raised to the second power. So if I were to simplify this, it becomes a to the second power, still divided by, I have not lost my fraction, my division symbol is still there, b to the second power. I'm distributing this power of 2 to everything inside my parentheses. So it becomes a squared over b squared. Now I want to see if I can simplify this. They have different bases. I have an a and I have a b. Those are two different values. So because they have a different base, I cannot just simply subtract the exponents. This is my final answer because they don't have the same base. So if you have an exponent, if you have parentheses raised to a power, you need to distribute that exponent, that power, to all the pieces inside the parentheses. Let's look at some more. This one looks a lot more complicated. Okay, so now I have 4 times x squared, all raised to the third power, and all that's divided by 5 times y, and all of that is raised to the third power. So I need to distribute this power of 3 right here. Everything in here is being raised to the third power, so that means this 4 is being raised to the third power. X squared is being raised to the third power. 5 is being raised to the third power. And then y is being raised to the third power. All of these pieces are being raised to the power of 3. So if I have 4 to the third power, so that simplifies. So what I have on the top is I still have 4 to the third power. X squared raised to the power of 3. If you remember from our products, from multiplying exponents, from raising a power to a power, I actually have to multiply these. So that becomes x to the 6th power. And then in my denominator, I have 5 raised to the power of 3. And then I have y raised to the power of 3. Now what I can do is I can start simplifying. When we have something like this, what we're going to do is I want you guys to actually multiply out and figure out what 4 to the third power is. Okay, and that's going to be 64. 4 times 4 times 4 is 64. So it's 64 x to the 6th power. And then 5 to the third power right here would be 125 times y to the third power. Now what I would look is see I have the same base, I have different bases right here. I have x to the 6th power, y to the third power, so these do not simplify any further. And then I could also see the 64 over 125, if I had that as a standalone fraction, can I reduce this in any way? Do they share any common factors? So we can still reduce our numbers here, okay, if they have common factors. These do not have common factors, so this right here is my final answer. 64 times x to the 6th power, 125 over 125 times y to the third power. Okay. Now, let's look at just one more problem and then we will be all done. Okay. So now we're still going to combine all the rules that we have learned into one problem that looks such as this. So first thing I'm going to do is I'm going to simplify all of this by distributing this 5th power into everything inside of its parentheses. Okay. So I'm going to distribute the 5th power into my a squared and distribute the 5th power to the b on the bottom. So this becomes a to the 10th power over b to the 5th power. And I still have to multiply all of that by 1 over 2a squared. I just brought this straight down. I cannot simplify this any further. They have different bases, so I cannot just do 10 minus 5 because they both have a different base. A and b are not the same thing. Now I can just multiply these two fractions together. I can combine these. And when we multiply, we just multiply our numerators, multiply our denominators, just like whenever we multiply, say, 1/2 times 2/3. When we were to multiply these fractions, we just multiply straight across. And we would get 2 over 6. Same thing. I'm just going to multiply straight across. So I'm just going to combine my tops and combine the bottoms, combine my numerators, combine my denominators. A to the 10th power times 1 is just a to the 10th power. Now I have b to the 5th times 2 times a to the 2nd power. So that's still going to be a 2a squared. And I'm just going to add, this is all being multiplied by b to the 5th power. Now if we look, what I can do here is if we notice I have a to the 10th power on top and I have a squared on the bottom, a to the 2nd power. I can simplify these. I can reduce these, okay, from using our rules that we learned in the beginning of this video. A to the 10th over a squared, this is going to end up canceling, and this is going to end up being, because 10 minus 2 is 8. Because now these are all going to go away. 10 minus 2 is 8. So now I really have a to the 8th power over 2 times b to the 5th power. This is all the way simplified. I cannot simplify this anymore. I have different bases. I can't simplify this too because there's nothing else to reduce it with on top, so I am all done. Okay, and I believe that's it. That's all I've got for you. Okay, so just a quick recap. If we're dividing numbers with exponents that they have the same base, all we're really doing is just subtracting them. Okay, because if we expanded it out, these cancel each other out, so we're just subtracting the numbers, and that's going to give us our new exponent. So 7 to the ninth over 7 to the fifth, 9 minus 5 is just 4, so it becomes 7 to the fourth power. And then if we have multiple pieces inside parentheses being raised to an exponent, we need to make sure we take that exponent to every single piece inside the parentheses. And so kind of very similar to what the distributive property is like, and then we can simplify from there. Okay, so I hope this video helps everybody, and good luck, and if you need any help, please don't hesitate to ask. Okay, thanks.